Hey everyone! So in this video I like to define exponents and calculate a few examples involving exponents just so we can get familiar with this operation. And so let me begin by saying that when you first learned about multiplication, how you learned it was as shorthand for repeated addition. And so let me explain what I mean by that. So here if I write down 4 times 7, you could tell me that this was equal to 28. But why is it equal to 28? Well, here 4 times 7 is really saying to look at 4 groups of 7, or add 7 to itself 4 times over, right? This number 4 here that's in the multiplication, that's telling us that we should really add 7 to itself 4 times. And that gives us our result of 28. And so this allows us to be really concise. Instead of writing really long strings of addition, we can instead quickly write one small little multiplication, right? So let's say I wanted to look at 10 times 25. In addition form, this would be 25 added onto itself 10 times. And that would take up a lot of space, but we can concisely write that as 10 times 25, and we can quickly calculate that this is 250 without writing out so much addition. And so multiplication is itself quite a common operation. It would be nice if we had a shorthand for repeated multiplication, a nice concise way of writing repeated multiplication. And so that's exactly what exponents are. Exponents are a way of writing repeated multiplication. So let's say I have 7 times 7 times 7, right? So the number 7 multiplied to itself 3 times. Well, here, using exponents, we can rewrite this as 7, right? The number that's being repeatedly multiplied, and then in the top right corner as a smaller number, we can write what we call an exponent, which is the number of times we're going to multiply that number to itself. Right, so this 3 is really telling us the same thing, that we're going to multiply 7 to itself 3 times. This is what we call an exponent. And so just to get used to what we're really looking at here, let's actually calculate what this comes out to be. So, 7 times 7 times 7, that's 49 times 7. Right, I'm just multiplying the first two 7s together to get 49, and we still have one more 7 to multiply in. And then when we do that, using a calculator, we get 343. So that's what this 7 with an exponent of 3 is equal to. And so here, let me also introduce some language around exponents. So here, let me rewrite 7, and let me rewrite this exponent of 3. The smaller number in the top right corner of the number that's going to be repeatedly multiplied to itself. So as we said, this 3 here is what we call the exponent. And the number below that's being repeatedly multiplied to itself, we call this number the base. And then when we look at this entirety, this whole group here all together, we call this a power. And sometimes this language gets a little bit mixed up. Sometimes people call an exponent a power too. That's not completely accurate, but it's happens so often that usually we don't think too much about it. But usually, when we talk about a power, we're really referring to the entirety, the result of this base and the exponent. And so some language about this, if you wanted to say this is 7 and this exponent of 3, you wanted to communicate this to someone else, you might say, you might call this 7 to the power 3. Or you might say the third power of 7. And then things that are raised to the power 2, numbers that are raised to the power 2 or the power 3 often get a special name. For numbers raised to the power 3, sometimes they're called cubes. So you might call this 7 cubed. And we'll talk about why that's the case later. So now let's calculate a few different examples involving exponents. I really encourage you to try these examples out yourself first, now that we've defined what exponents are. And so when you're ready, feel free to resume the video and we can go over these together. So 2 to the power 5, that's what we have here first. This is telling us to repeatedly multiply the base of 2 5 times, right? So here this is going to be 2 times 2 times 2 times 2 times 2, right? Here this 5 in the exponents, that's telling us to multiply 2 to itself 5 times. Well, here we know 2 times 2 is 4, so that's these 2's here, that's 4. Multiply with 2 again gives us 8. One more time gives us 16, and then doubling that again, well, doubling 16 gives us 32. So 2 to the power 5, that's equal to 32. And so one thing I want to warn you about, it's a very common mistake to make when you're first learning about exponents, is that 2 to the power 5, this is not the same as 2 times 5. Right? Exponents do talk about multiplication, but we're not multiplying these two numbers together. That 5 is just telling us how many times we should multiply 2 to itself. Right? So 2 to the power 5, this is not equal to 10. Right? It's equal to 32, as we just saw. Okay, what about 9 to the power 2? Or we also said that when we raise something to the power 2, we might call it a square. So we might call this 9 squared. What is this equal to? Well, this is 9 times 9, right? This 2 is telling us to multiply the base to itself 2 times. Well, 9 times 9 is equal to 81. And this last example, here it involves fractions, but it's really no different than the previous examples. It tells us how many times we should multiply our base to itself. Well, in this case, the base is this fraction 2 over 5. And we're going to multiply to itself 3 times. And luckily for us, multiplying fractions together isn't all that bad. We just multiply straight across, numerator to numerator, denominator to denominator. And so this is really the same as 2 times 2 times 2 over 5 times 5 times 5. Well, 2 times 2 times 2, we already computed that a little bit in the process of computing 2 to the power 5 earlier. And we get 2 times 2 is 4, times 2 again gives us 8. And then what's 5 times 5 times 5? Well, 5 times 5 is 25. And then multiplying that again by 25 gives us 125. So 2 over 5 all cubed is 8 over 125. So one way to really understand something is to try and reverse the question and see if you can still come up with the right answer. And so instead of taking a number and an exponent and seeing if you can calculate the result, let me instead ask you, can you think of the exponent on the number 3 that will give us the number 27 as a result? What power of 3 gives us 27? And then my next question is to ask, can you think of two numbers? Can you think of what number raised to what power gives us the number 16? And there are actually multiple answers to that second question. And so let me try and ask you to think of a few. Okay, so hopefully you've had a moment to think about that, and if not, pause the video and give yourself some time. But let's go over these examples here. So the first one says, what power of 3 produces 27? Well, here if I take 3 and I raise it to the third power, this exponent tells us how many times we're going to multiply that base, right? That's going to be 3 times 3 times 3. Right? That exponent is telling us we're multiplying the base to itself 3 times. Well, 3 times 3 is 9, right? That's this first multiplication here. And then 9 times 3, that last multiplication, gives us 27. And so this is the right exponent. 3 is the necessary exponent. Now, what powers produce 16? Can you think of any numbers raised to a different power, or raised to a power, to give us the number 16? Well, one nice example is the number 4, right? 4 raised to the power 2, that tells us 4 times 4, which we know is 16. And then a similar example is 2 to the power 4, right? 2 to the power 4 tells us multiply 2 to itself 4 times 2 times 2 times 2 times 2. And you can notice here that 2 times 2 here is 4, 2 times 2 here is 4, and together that would give us 4 times 4 is 16. And then another example, which is kind of a sillier one, is 16 to the power 1. But it's just saying, don't multiply 16 to itself at all, just have one copy of the number 16, and that's equal to 16. So these are a few different ways we can use powers to represent the number 16. And one thing I want to mention here, just so I don't add any confusion, so here, we have 4 squared, 4 to the power 2 gives us 16, and we have 2 to the power 4 is 16. And so I don't want you to get confused that we can reverse the base and the exponent and get the same result. Right, so actually, in general, if I have a number raised to a power and I switch their roles, if I switch the exponent and the base and I have b to the power a, these actually are usually almost always not equal to one another. Right, maybe let me just give you a quick example. If I have 2 to the power 5, we saw in a previous example that was equal to 32. Now if I try and reverse this and write this as 5 to the power 2, well, this is 5 times 5, which is 25. That's not equal to 32. And so in general, when we switch those bases and the exponents, we don't get the same result. Another thing I want to warn you about while I'm giving you warnings is try and be really clear when you're writing exponents. So let me write that down. Be clear and careful when writing exponents. So what do I mean by that? Well, here, 2 to the power 5, that exponent's written as a smaller number tucked in the top right corner of our base. If you write very quickly or a little messy, it might look like 25, right? If you write 5 a little bit too big, maybe a little bit too low, it'll look like 25. And again, as we saw above, these two here, they're not equal to one another. So be very careful when you're writing exponents. Make sure that exponent is a little bit smaller and it's raised up high enough so it's very clearly an exponent. So another thing I'd like to warn you about is expressions involving negatives and exponents. So let's look at how these two different expressions compare. Negative 4, in parentheses, raised to the power 2, and negative 4 raised to the power 2 without any parentheses. So in the first example, right, that exponent tells us to square the base, multiply the base to itself. And in this case, the base is this entire negative 4. Right? This is negative 4 multiplied with negative 4. And here, two negatives, when we multiply them together, give us a positive result. This is positive 16. Now, what about the number negative 4 squared? Well, actually, here, this square really only applies to this base of 4. The negative is really separate and gets applied afterwards. And so this might look a little confusing at first. You get used to this as you work through more different examples and problems and through more classes. But this is something it's a very easy mistake to make, or to mix up these two. But here, negative 4 squared is the same as negative, 4 times 4 is 16. And so we get a different result than above. That square is not applied to that negative sign in the bottom example. So another thing I should mention is that exponents make numbers very big, very fast. For example, if I have 9 raised to the power 2, in other words, 9 multiplied to itself twice. So this is one example we computed earlier, it's 81. And then if I increase that exponent by 1, right, that's 9 times 9 times 9, or in other words, 81 times 9. And I can't do this in my head. If I use a calculator, I get 729. And if I multiply 9 to itself once more, I end up with 6,561. And we can repeat this process and go over a few more examples, but let me go over one more a little bit further down the line. I'm still not using that large of an exponent. I'm only using an exponent of 10 here. But when I raise 9 to the 10th power, I get this really massive number here. So I get 3,486,784,401. And so this just goes to show that even if I use a rather small exponent, we get a really, really large number. That exponents actually make numbers grow really, really fast. And so oftentimes, when we're trying to compute some exponents outside of the smallest examples, we actually will usually need to use a calculator, or we'll leave it in exponent form. Right? So I might prefer to write 9 to the power 10 over 3,486,784,401. And so how do we write something like this in a calculator? Well, this is done using the caret symbol. So in your calculator, there should be some symbol that looks like this arrow pointing upwards. And so this is used to denote an exponent. The thing that follows this caret symbol will be the exponent of the base. And so how would we write this? We might write this as, 9 to the 10th is really the same as 9. And then we have this caret symbol, 10. So that's how we can write it in a calculator. And so in your computer, how you would write this symbol here, well, this is really the same as this comes from holding your shift button. And on most keyboards, it'll you'll have to press the 6 button afterwards. So you'll hold shift and then you'll hit the number 6 to get this caret symbol out. And so this is how we can write exponents using technology. So earlier I said that numbers raised to the power 2 are often called squares, and numbers raised to the power 3 are often called cubes. And I'd like to talk about that a little bit more now to wrap up this video. And so for the sake of having a very concrete example, let me look at this square with a side length of 6. And because squares have identical side lengths all around, this side length would also be 6. And so what would the area of the square be? Well, the area of a square is its length times its width. And so that would be 6 times 6. Well, we just came up with another way of writing this, 6 times 6. That could be written as 6 to the power 2. And so this square with a side length of 6, its area is 6 to the power 2. And this isn't really any different for other examples. If I had a side length of 10, the area would be 10 to the power 2. If I had a side length of 15 for this square, the area would be 10 to the power, or 15 to the power 2. And so in general, because the area comes from just raising the side length to the power 2, we call anything raised to the power 2, we call it a square, because it can be seen as an area. And similarly, for cubes, we can view numbers raised to the power 3 as the space inside of a cube, or its volume. Right? Let me give you a concrete example. Let's say I've got this cube here with a side length of 4. So all the other side lengths are 4 as well. And the space inside of this cube, it's called the volume. This three-dimensional space. And it comes from, for a cube, multiplying the 3 different kinds of sides together, the length, the width, and the height. So that would be 4 times 4 times 4. In other words, 4 raised to the power 3 would be the volume, or the space inside this cube. And this is true in general. Even if I chose a different number than 4, that side length would be raised to the power 3 to get the space inside the cube, the volume. And so for that reason, anything raised to the power 3, it can be seen as the space inside of a cube. And so we call that, raising something to the power 3, we call that a cube.